Alrighty, should we start? Cool. Hey, I'm Matt. I am ever so slightly jet lagged. Anyone else on the European time zone? Yeah, oh my God, we're all going to fall asleep, aren't we? Please don't. We've got a buzzword to talk about. We've got Nano Services to talk about, which is, I think, a really interesting concept. I'd love to hear your thoughts too on it. It's basically saying in this world where we have the cloud and we have all these services and we have large teams developing richer things than ever, is there a way of working that's a bit different? Is there a way of architecting our software that could be a bit smaller and reusable? We'll go into that. We'll also go into Elasticache, deep dive into that a little bit, primarily Redis, because Redis is just the most phenomenally fast and flexible thing. If you don't know it, we'll look a bit at that as well. So, two things to look at. We'll easily get through it within the hour, I think, so plenty of time for coffee afterwards. And do grab me throughout the week if you want to talk about it, because it's, I think, really cool. So I'm from the BBC. I'm the head of architecture for various bits. Has anyone not heard of the BBC? Just checking. I thought so. The BBC's, Wikipedia describes it as the largest broadcaster in the world. I think the word broadcaster is getting a bit tough nowadays, isn't it? Everyone's a broadcaster. Everyone's in it. But it is huge. A lot of it is UK only, regrettably. But there's an awful lot global as well, as I'm sure you know. And there's just a random set of some of the websites, as well as dozens of radio stations and TV channels and all that kind of things as well. It's got this wonderful mission to entertain, educate, and inform. You know, it's not for profit. It's just there to do those things. And when the world stops needing entertaining, educating, and informed, it'll disappear. But there's quite a lot of that required still, right? So it's a great organization just trying to make the world a better place. And it wants to do as much as it can, understandably, and it tries to do as much as it can, but it's got a fixed income. And so the real challenge is, how can you do that breadth? How can you let a reasonable number of developers, and an awful lot of people making content, to be honest, do such a wide variety of stuff, in an efficient way, with a fixed resource, fixed income? That's the goal. How to be efficient, right? Velocity, how to develop stuff. That's a problem we all have. To take, for example, the one on the right is BBC News in Korean, primarily designed for the North Korean market. That's North Korea, the one country that doesn't have the internet. But that's how much the BBC is trying to do. There's a download button on there somewhere, if you're wondering. We'll maybe not go too much into that process, but there's so much going on, so much good stuff going on there. This is the most popular. Have you seen this? It's fantastic, isn't it? The comedy timing of this poor guy being interviewed on the rolling news channel the BBC has, when his kids, and then his other kid, and I love when the mum comes sliding in to rescue them. It's just the perfect comedy timing, isn't it? Hundreds of millions of shares around the world. That moment. Poor guy. It was all choreographed, by the way. No, not really. Poor guy. He's been interviewed since as well. He's ashamed. It's very funny. Yes, so we're here to talk about, let's call it a pattern, Nano Services, an idea which you could apply to what you're working on as well. And we've done an implementation at the BBC that's now powering some of the most important things we do with BBC Online. It's, as you've probably guessed, about making things small, units of logic that are kind of understandable, simple, but also reasonable in themselves. They do one thing well, and they could then be used in all kinds of different ways, just like Lego bricks. We'll come on to that. And it works behind the scenes by something a platform we built we'll go into, all on AWS, making really heavy use of Elasticache. So we'll do a bit of background. We will look at this Nano Service pattern. We'll look at the BBC's implementation. That's where we'll go deep on Elasticache for a few minutes. And we'll end with the pros and cons, because like everything, there's good and bad about this way of working, right? So it's an option to choose. Is that all right? Good, because I haven't got another plan. Okay, do we all know what Elasticache is? hopefully. Basically, I'm obviously not from the Elasticache team, but it's a managed service that basically runs your Redis or your Memcache on top of an EC2 for you for a slight extra cost. I don't know a lot about Memcache other than it's very basic and there's not a lot of reasons to use it. Redis, on the other hand, is brilliant. Elasticache automates a lot of the basic stuff. It helps you with the replication and sharding a bit. It can do backups for you, and they've obviously optimized quite a lot of the servers as well. So I can't think of a very good reason why you wouldn't use Elasticache if you wanted to run Redis, unless you really wanted it to be on the same box as your software. But it's very easy. We've used it from day one of needing Redis and haven't looked back. It's great for that. Different sizes are available. You're very rarely CPU limited, but memory or network is normally your point, so you can pick different size ones, including the T2 instances, the T2 EC2 instances, where you get a percentage of a CPU, which can be useful for low traffic ones. And Redis itself is at its heart a key value store, but has many different data types, including lists and sets and that kind of thing, and you can do all kinds of rich stuff with it, as we'll look at in a minute. You can even do things like queues. You can also do Lua scripting, so it's kind of the same as kind of database store procedures. You can run Lua on the Redis instance. You have to be careful because it all runs via the same process, so it'll block any other calls. So it wouldn't be a good place to do some big calculations, but for kind of basic scripting and atomic calls, it's very, very useful. And there's also pub/sub SNS-style notifications if you need to do that as well. Although you have to be a little bit careful how that scales, because if you have many hundreds of boxes, again, it's a single process thing, so it can take a while to share that out. But there's all kinds of stuff you can do. There is sharding if you need to distribute over multiple boxes. That comes for free with Redis. There's replication as well. If you've got a read-heavy environment, you can read from the slaves. It's always a single master model, but you can read from the slaves, and it'll fail over to the slave if the master fails as well. The Elasticache team launched a few weeks ago the ability to grow and reduce the size of your sharding cluster, and for the data to be kind of spread out automatically over a period of time as well, which is kind of cool if you've got load that increases over time. So we will delve into Elasticache a bit more in a bit. First, a little bit of background on the BBC. They have a few hundred developers, so you're reasonable size, broken down into many small product teams. And their journey over the past 5 years has been the same as everyone else. It's moved from their own data centers to the cloud, predominantly Amazon, of course, that's why we're here. It's gone from fewer, bigger releases, because that's what you did in the old days, right, with your big data centers, to continuous delivery. Not quite continuous deployment normally, but we've got things being released every few minutes during working hours. There's an awful lot of stuff being continually updated. All good, healthy stuff, right? And then we've also gone from these separate single-disciplinary teams to the wonderful world of DevOps, where everything's multidisciplinary and you get that flexibility to do what you want. Cloud, CD, DevOps, it's the bandwagon we're all on, right? It's all good stuff. Except there's always downsides, right? There's always pros and cons, and particularly with continuous delivery and DevOps, they can be quite expensive or let's just say distracting, right? So it's fab that you can release something every 5 minutes, but if you don't really if you haven't properly monitored it, if you haven't got a really good build and test pipeline and so on, it can become very expensive. And likewise with DevOps, it's brilliant that you have that flexibility, but when your developers realize they now are network engineers and security specialists and all the rest, it can get quite tough, right? You suddenly have to become a jack of all trades. And sometimes the developer who used to be brilliant at just writing CSS and making beautiful front-end web pages suddenly finds themselves configuring IP tables or understanding networking subnets. It's quite challenging that. You can spread yourself thinly. And the one of all my years at the BBC and elsewhere, the one of all the phrases we hear and all the buzzwords, the one I've always loved the best is this one: make the common things easy and the special things possible. It's kind of come from, I think, Larry Wall was the earliest reference to it with Perl. It was only 15 years ago now. And it's so obvious as to kind of always not be worth it, right? But it's actually really hard to do. You normally tend to either the first line, or the second, right? So our old data center setup was very much good for the first one. We had a bunch of PHP boxes and Java boxes, and people could write their stuff and upload it, and everything was fine. It was great. But as soon as you wanted to do something different, sorry, we don't have that capability. And so you didn't make the special things possible. On the other hand, the cloud has been very good at making the special things possible, right? There's an awful lot of buttons in the AWS console. Doesn't mean you should press them all, right? It is very hard to become good at all of those things. And sometimes, all of a sudden, setting up a simple web server can be quite hard, right? If you choose to do it by spinning up your own EC2s and what's a load balancer and blah, blah, blah. And before you know it, you're reinventing a lot of stuff that a lot of people have already. So it's kind of really hard to get that balance right. You really want to be solving every problem once, right? No matter how big your organization, once somebody's worked out how to set up the perfect build server or the ideal test setup or the rest configured Nginx or whatever like that, you kind of want to go, right, bank that, everyone needs that, move on to the next thing, right? In a large organization with dozens of different teams, it can be really hard to share that knowledge. So you want to start standardizing that, not forcing it because you want to allow the specialist to happen, but forcing that stuff, right? Which then lets you spend more time innovating on whatever it is you really want to be doing that's different, which leads to your better experiences. On the other hand, you do want to empower teams to do whatever they want, right? Because you want that freedom from which you can then go and pick the right tool for the job. You want to press those buttons in the console because that lets you make better products, right? So hard to find the right balance between those two things. This is a screenshot from Chartbeat. Do you know Chartbeat? Analytics tool used by most journalistic websites around the world to track engagement. Every year they summarize the most engaging sites that they saw on the internet. This is the most recent one from 2016, which was quite a big news year. Number 538, with a phenomenally popular site of everyone looking at the US election results going, wasn't they? Followed by, at number 2, Britain throwing away its economy with the BBC's coverage of the Brexit Live blog there as well. And you can see the BBC's also in number 7 and number 8. We're in the top 10 more than anyone else, top 100, I think, more than anyone else as well. We have a phenomenally popular site. Is that a blessing or a curse? As developers, it's a curse, right? It is really hard to scale that far. And we're using CloudFront and other CDNs and got all kinds of caching and all this clever stuff in front of it, but it's still very hard if you want to offer a really good experience that varies depending on the user and the location and so on. So, not only do we have this desire to be efficient, to reuse, but we also have this large problem of needing to be extremely scalable as well as super reliable for these big moments. And you don't want that problem to have to be solved several times over and over again, right? Microservices are fab. My colleague Stephen Godwin talked about them this morning in another talk, and they are, of course, very flexible, great ways of building things. You've read all the blog posts, been to all the talks, right? Everyone knows it's great. Multiple teams can get involved, each building their own microservice. You can use different tech if you want. Its deploys are smaller and safer than the big monolith because you've got these individual components, and they can also be more shareable and more flexible and scale their own way as well. They are very powerful. They also have a lot of cons, like everything in life. They have that maintenance overhead because suddenly you've got all of these things that you're looking after. You have the comms overhead, because if you're talking over, say, HTTP, as most do, there's that natural, not just the latency and natural transaction cost, but also the error handling ones if one doesn't respond and so on. It can be quite expensive, that. Multiple versioning can be a real problem. If you're making a breaking change to your microservice that's used by other microservices made by other teams, always a challenge, right? Do you run 2 side by side? That doubles your maintenance costs. Do you have some backwards compatibility layer? Do you wait for them to update? In large organizations, it can take months, years for your dependencies to catch up with you. So this can always be very big, hard in a big organization. And then harder to refactor as well, because once you've got these in place made by different teams, coming along at a later point and saying that's not cut up right involves changing a lot of teams. Very, very hard to do in practice. And there's an inevitably cost of running all these things as well. So nothing new there, and the web's full of people talking about this stuff. For example, on the Wardley site, Sand Mac makes all those kind of negative points as well, talking about the fallacies of distributed computing, that natural problems of latency and eventual consistency and so on, versioning, configuration management. Nothing new there. The Wikipedia article generally is more positive, talking about all the benefits of microservices. That's quite good. But if we do scroll down to the bottom, there is a bit on Nanoservices, which goes, Nanoservices are an anti-pattern. Yeah. Oops, that's the problem. That's the whole point of today's talk. Oh well. Well, if we look to be precisely what the quote is, it's where the problem is when the overhead, the communication and maintenance and so on, outweighs its benefit. And so, okay, fair enough. If we want to go smaller, then we're going to have to find some way of getting rid of that overhead. We'll get there. So, what is a nano service? It is responsible for a single thing. It does one thing well. The Unix philosophy, if you know it, it's a bit like kind of the Unix commands, sed or grep or awk or whatever. They do one thing really, really well. They're super powerful. They're very flexible. They take lots of arguments, but they do one thing well, and you'll know what they do. And you don't really care how they work. They're a black box. You just know when you request something from it, it'll do it very, very well. That's a nano service. So it's probably smaller than the microservice. And, microservices are bigger than small, right? In general, they don't get too small for the reason that Wikipedia told us, but they could be as small as this. There's no hard and fast rule, is there, about how big these things are. In general, they are smaller. Not 1,000 times smaller. Clever people. Just a bit smaller. They are almost certain to call other nanoservices, because in themselves, they're too small to do your whole system. So they almost certainly come together to make something richer, just like microservices often do. And they are, perhaps this is one of the definitions, they are the ideal size thing to change and then to release. And to go, okay, I want to change this particular bit of behavior, and I want to get it out there. And I want it to see how that effect is, maybe kind of blue-green it or multivariant it or something like that, so that you can kind of see the impact of that. And then if it doesn't work, you can roll it back or whatever. In a world, just imagine a world where the cost of these things is so small. You're not worried about having loads of different things changing going on at once. Or the cost of deploying them or running them. You found some way to overcome that. How great would this be if you've got these lovely small things that you can be working on and releasing and updating and so on? Really simple example. Say you're building some kind of e-commerce site. Here's two things you might have. Get customer order history and place order. Yeah. Two basic commands you might have. You might have put them in one microservice, right? Because they're about order handling and user handling stuff. You would have probably put them in one microservice, but they definitely would be two separate nano services. And get customer order history is kind of some kind of data warehousing activity, right? You may be querying do some big database query or something, whereas place order is probably more talking to your stock control system and delivery system. So they're kind of related, but they are different, right? So being able to treat them separately and on different days to release them, being sure you're only releasing one bit, that's kind of the ethos. Does that make sense? Right. Real-life example. We use nano services mainly for either making web pages or for making APIs that then go on to power web pages or apps or other things we have. So this one, for example, the BBC News homepage, the highest profile page the BBC has. The box, the first bit with the reddish news and the links, that's been there for a while. That doesn't come through. But the whole bit you can see beneath it, all those headlines, that is a nano service. It is one nano service, but that would be too much for one to do. So it then calls other nano services to get the bits. So, for example, the main headline would be a nano service. That timeline to a right would be one. The list of headlines on the right-hand side, that would be another one, and so on. And then behind that, there would be more nano services doing the kind of data layer, the modeling to fetch that data from whatever database it is and to return that to make this page. All in all, I think there's about 30 nano services responsible for making this page. If you include all the bits, we'll have a look at a demo in a while. Here's another example. This is the page that happened to cover the Olympic Games. Last year, the Olympics are a massive thing for the BBC. They spent just under $1 gazillion on rights. It's it's the biggest event in the world. It's huge, and just like the other BBC News homepage, the biggest page we have. This is the biggest event we have, and again, we've used nano services to do it. So I've highlighted in blue. The whole page is one nano service, which happens to call other nano services, like that one in yellow, and these ones down here for these different bits. But even they were too much, and they then split it up. So, for example, on the right, where that medals table is, that would be a nano service. Likewise, that kind of video carousel on the right, that would be a Nano service. And there's a few more on there as well. So you can kind of carry on like that. Does that make sense? But it's great, because what you can do is, say you found a bug. Say in the middle of the Olympics, you found a bug with that carousel. You can fix it and release it and be sure you're only affecting that bit. Whereas I led the architecture of the previous Summer Olympics in 2012, which was in London, and so massive for the BBC. And back then we did have a monolith architecture. We didn't have this. And we found bugs in the middle of the games, and we didn't dare fix them, because we were just so petrified of making that change in the middle of the Olympic Games. Now, not a problem. We just quite happily let these things go out, even during the major events, because you're only making such a small change. Let's look at that example. So that Olympics page is actually a very generic page. You can cover any event, be it an election or a music festival or whatever. So it's a generic event page. And do you remember how it's split into bits? You can kind of draw it as a graph, this tree of Nano Services. So the various different bits of the page. And do you remember on the right-hand side there was a medals table? So this is kind of what's going on behind the scenes, these different Nano Services. But the beauty of it is, now you've got these things that are services. You can call them if you want as a REST API, you can get them, and you can then use them in other ways. So the medals table we then use on a dedicated medals page that looked a bit like that. We then made a multilingual medals, which actually made by different teams. Not all of these things are made by the same team, of course. So that the specialists in multilingual sites then made a variation that worked in different languages, such as Arabic, and it appeared on the Arabic news homepage like that. Behind the scenes, that medals module, so those ones so far have all been ones making chunks of HTML, but there's no, a Nano service can do anything, so it uses another one that returns JSON for the data of what medals have been won, which of course is getting its stuff from a database that knows how to do that. And then once you've got that as a service, here's a nice clean list of all the medals that have been won. You can start to do other things. You can start to send mobile alerts, push alerts to your app. That's what we do, looks like that. Or you can start to send it to, we have apps for internet-connected TVs, so it kind of sends it to that. Looked a bit like that during the Olympics last year. So you have all of these Nano services made by different teams with different specialities, but coming together, a bit like microservices, but far more fine-grained, and it works rather well. That is actually, if you were to take our event page, that one which can cover Olympics and elections and music events and everything else, and actually show out theoretically all of the Nano services that could be called as a circles, that's what you get. And that's kind of unreadable, right? So that's kind of a bit bonkers. But we don't really draw it out that way, so it doesn't really matter. And that's only what, the very worst case, if there was a soccer match on that happened to include an election result in the middle of a music festival, that kind of, it would be kind of impossible to do that, but it's theoretically there. And so you have, dozens of different teams building their specialist bit in that. I think we probably need to work on a diagramming. If we zoom in a bit, you've got no chance of following those lines, right? It doesn't make any sense. We probably could do a better job of improving our tooling here. But again, it doesn't really matter, because you've got these things that are responsible for doing one thing well, and they're well isolated. And there's, they behave, as long as they behave correctly, it all fits together. I don't know if you can read some of the words. There's things like cricket in there, the fine sport of cricket, if you know it. Things showing the results for that. There's something around pagination, something around translations. You get the idea. Things that you can kind of get what they do. But are there as a service for you to use and build stuff up in different ways. So how's it working? All on Amazon. Basically, if you're a developer and you're wanting to make one of these Nano services, you simply stick it in an S3 bucket. We've actually built an API to help you do that, but it's basically sticking it in an S3 bucket, just as a zip, a tar of your source code. And then when somebody needs to run your Nano service, it runs on a platform, which is a bunch of EC2s we have that do it. And basically, that will load in the code, your code, and we'll run it. And chances are, vast majority of the time, the code's already loaded in. But if not, we've kept that. We've managed to speed that up so it can load most things in within comfortably under a second. So there's not much of a hit. So most of the time, it's already loaded up and ready to go anyway. So you have a very fast response time. And when one Nano service wants to call another, because it's all in one platform, it's not a problem. It can just run it. We cache stuff. This is where the Elasticache comes in. We cache the response of everything. Often you need to go off and make other calls to other things to get your data that powers it and so on. Not a problem. We also use Elasticache as a queue to track it all. And we also use Elasticache to store the metadata of what's going on. So 3 different ways in which Elasticache is being used. Let's delve deep into them. So we store the output of everything. So do you remember the tree of all those things? We store every one, whether it was directly requested by a user or not. We store the whole lot. Why not? It's so incredibly cheap to stick stuff in Redis. Stick it in there. It might be useful. We just keep sticking it there until it gets full up. And then Redis will automatically discard the older stuff. Nice and simple. So a couple of screenshots of the most read on the news homepage, for example, and then the data behind it that's powering that. They're 2 different Nano services that, of course, work together. We cache both of them in Elasticache because we can. And that way, if the data's not directly called, but if it's used in some other way, on a different page or maybe by an app natively or something, it's there and super fast. We're storing up to 8 million items, seems to be where we are. We're sharded across 4 reasonable-sized M4X large boxes. Not a problem storing millions of items. Redis, if you don't know, stores everything in memory. It doesn't need disk to do it. But it obviously depends on the size of your stuff, but you can easily store many hundreds of gigs in there, no problem if you need to, or many millions of items, depending on your size. Our sizes vary up. They go up. We're not storing huge stuff. They go up to about 5 meg, our sizes. You can, of course, get up to 500 odd meg in Redis, but we don't quite get that far. But we just shove it in there because it's just so quick and easy. So that's content. Next is the metadata. So what we do is we also track every call to a Nano service and what's going on behind the scenes. So this tree of the relationships between it is also stored, built up, of course, initially by the code going, I need to run this other one and so on, but then remembered. And what the cool thing about that is then when some data changes, so say a medal comes in, this is back to the Rio example from a few slides ago, say a medal comes in the middle of the games, because we've got that, we know what will be interested in that new medal. So we're kind of forward cache busting, if you like, so we can immediately update the page or send the alert or whatever it is for that event. So we've got both the benefit of caching from millions of users hitting you, but also that ability to kind of cache bust and get stuff out there as quick as possible. Yep, that's kind of what we said. And again, that metadata is just so incredibly simple because you have, especially with Redis, you have the sets, you have the keys that you can very quickly look up. The cost is unbelievably trivial. Shove it all in there and it's there for multiple EC2s to access to get the state. We store the relationship between them both ways around. A has requested B and B has been requested by A kind of modeling, which is one of those things that, of course, you need to get that right, because if A thinks it's B's using it and B's forgotten that A needed it, then you can end up with bugs. So you have to remember this is not a relational database. It doesn't have referential integrity or anything like that. But if you get that right, and you can use Lua to help you make sure that's atomic, so you never have one and not the other, then it can be very flexible. In fact, there is a whole section on the Redis website about building a hexastore, which is basically a GraphDB, where you basically store all the permutations of relationships between things. And it is basically, Redis is very, very powerful. You can use it in all kinds of ways, such as to do relationships between things. And then Redis for queues. We use Redis as a queue. The reason why we use it as a queue is because it's phenomenally fast. No offense to SQS, but you can get comfortably under 5 milliseconds, often much quicker than that, end-to-end, from one client to another. And when it's that quick, you can even use it internally on one box, right? You can begin to think about it as a way of parallelizing what's going on. No problem at all doing 10,000 messages a second. That we've got it on actually a far too large a box, because that's a box that's very high in memory, and typically queues don't use a lot of memory. But all Elasticache instances only use one process, so it doesn't matter how many cores they have. It all uses the same one. So I presume you could get such a similar level on other boxes as well. And then behind the scenes, it's actually doing up to 120,000, I think we saw, 120,000 individual commands a second, because we've got some extra logic in there. It's very simple. If you don't know your Redis commands, it's basically a list. That's what a queue is, isn't it? A list, right? And you push something onto the front, L push, left push, and then you can R pop, right pop it off the end. And the B R pop is telling it to hold the connection open until a message comes through. So if it's not always something there, it'll, like SQS, it'll hold the connection open for a certain period and wait for a message to come through. And what we do is a bit more than that. We also not only write to the list, but also write to a set. And the beauty of a set is you can kind of directly key into something, so we can tell when there's a duplicate. So this is now a deduplicating queue, which is a fairly advanced feature for queues. So if you're worried about duplicate stuff to try and reduce the amount of repeat activities done, you can very easily implement duplicate behavior on there as well, which is very cool. Don't forget, before you start throwing away all your SQS implementations, that it's not a full queue solution. It doesn't really work with Redis replication because both putting something on a queue and taking something off of write operations, so you don't get a lot of benefit with replication other than maybe a little bit of resilience in case your master fails. And it's inevitably lossy as well because as I'm sure you know, when you take something off a queue, you have to acknowledge it, otherwise the queue will send it again, assuming that you failed to process it. That doesn't happen by default with a list. Once you've taken something off the list, Redis doesn't care. There is, if you want to kind of emulate that behavior, the best of all the 200 commands Redis has, this is the best named one, BL popple push. Blocking, write, pop, and then left push. So take something off the queue and put it onto another queue straight away, with the timeout being how many seconds you're willing to wait for if there's nothing there, for it to wait to give you something. The idea being that you then have this in-progress queue that you can do something with, which you can monitor. So presumably once you've done the work, you then take it off the in-progress queue, because it's your way of tracking the things that perhaps need to be rerun if your process crashed halfway through. So you need to take it off once you're done, and then you need another process to be watching that in-progress queue, and after so many seconds decide that it needs to be rescheduled again. So it is quite manual, but it is possible to do that if you're after the phenomenal performance of Redis. Another trade-off would be that metrics aren't so obvious. Of course, Elasticache has CloudWatch has plenty of metrics about Elasticache, but it's not a queue, so it won't tell you how many things are on the queue or how long they've been on the queue or the classic queue metrics. You would need to implement that yourself, but it's not hard. We've done that. And there's inevitably a scaling problem there as well because you haven't got the whole of SQS and its wonderfully parallelizable, scalable stuff going on there. But as I said, you can do 10,000 reads and writes a second, so maybe scaling probably isn't a problem. And of course, you don't get all the advanced features of good queues either. But if you just want something that's incredibly quick, Redis is a very interesting way of doing queues. Here's an interesting one. So we all know the good cross-AZ behavior, right? That you should always spread your instances across availability zones. So if one fails, you don't have an outage. A little bit harder with Elasticache because you have got one master. That's how Redis works. It will automatically fail over to slaves if you've got replication. So that's how you typically do it. You have your slaves in a different AZ to your master. All very good. But one interesting thing is that if you're using Redis a lot, it can be 4 times slower to communicate to a Redis in a different AZ. So since you've only got one master, if you've got 3 AZs and one master, 2/3 of the time you're going to be in a different AZ to that master, right? I don't know if you can see the small bit at the bottom. There's a simple Redis benchmark you can do, and if you say in serial, do a series of GET requests to an Elasticache box, you get 1,800 a sec if it's in a different, 1,800 GET requests a second if it's in a different AZ, and 7,200, 4 times as much in the same AZ. Now those numbers are still huge, right? 1,800 messages there and back a second across AZs. It's pretty phenomenal. So it's not as if we're calling out a problem with cross-AZ networking here. But if you have got a very fast application that's doing an awful lot of Redis calls, you can get up to, on this example, 7,000 messages within one AZ going to an Elasticache box. That blows my mind. That's 7 messages every millisecond, there and back in serial. It's pretty incredible what Redis can do. What is interesting then is if that performance is important to you, and it's really easy to write applications that end up doing an awful lot of to and froms with Redis, is to actually have separate instances of your application within one AZ, which is a different way of recommending how you do AZ failover. But what it means, of course, is that if one AZ fails, one of your whole instances goes and you rely on the other. So you kind of got two very independent things running, knowing that one of them can do the job if the other one isn't available. Okay, so that's Elasticache. Let's quickly jump back to Nano Services. And as you may have guessed, there's a whole ecosystem around them. They are these things that you develop, release, test, maintain independently. So they have their kind of all the things around them. They can have multiple versions, not a problem. They can have clear ownership. They can have some files if they need around them. Single-click deploy becomes possible. Do you remember we're just uploading to S3? And I didn't draw on the architecture diagram, but there's also a concept of a versioning database that picks which version to use by default. So, bringing out a new one just means copying it to S3 and updating one row in the database, saying, yep, that's the one to use. Yeah, Nano Services are connected to each other, as we've seen. You can have analytics about how they're doing, how many times they've called. You can then, from that, derive how expensive they are. You can have multiple users, multiple tests, and code. We've written all of this in Node.js, both the platform itself and the Nano Services, but I can't think of any reason why it has to be that. I think it would work with any language. And we happen to use React as well as the way of making the HTML components, but it doesn't have to be. So let's jump to a quick demo, if it lets us. Sweet. Okay, so this is the BBC News homepage. We had arranged with Prince Harry that he'd announce his news just in time for this presentation to give you one. Unfortunately, North Korea have launched a ballistic missile to take it off the top headline. So Prince Harry's only number 2 today. And there's a brilliant one. Have you seen this one about radioactive? Some guy has intentionally made some playing cards radioactive so that he can spot them and cheat. Just given we're in Vegas, if you need some help later. And interesting idea. Anyway, here is the BBC News homepage, complete with ad-blocked ad. It's funny how you ad-block your own site as well, isn't it? And that's that. And as I said, that bit you can see there is a Nano service. If I flip here, that is the Nano service. It's obviously lost its theming somewhat, and the images have broken without the kind of parent CSS and JavaScript in there. But you get the idea? That is a REST API that you can call to get that Nano service. And to pick another example, the next thing down here, this must-see, shocking scale of US drinking water. That's that one there, because for some reason it's lost even more of its styling. But again, that's another Nano service. You get the idea? And so that you can carry on with this. So another one, most read, that we happened to have on a slide earlier, you may recall. Again, where's that gone? Styling's gone, but that is that Nano service, right? So you could then take that and put it in another page if you wanted to as well, without worrying about how it works or where it gets data from or anything like that. It's just there as a service to use if you wanted. To have a look at the code, all our code's in GitHub. So here's an example of that particular one, and you can see it's kind of got a bit of a documentation, example of the parameters it takes, and so on. If we quickly look at the code, 2 files, right? Because it's really quite simple. But this is the lovely thing about it. It's simple enough that you can understand it and you can develop it and change it and you feel confident doing it. And if we look at I don't think they're very big. This one's 40-odd lines. And this one I think is a bit longer, a couple of hundred lines. But you get the idea. Obviously, I'm flying through this, but not a lot of code to do that. This is calling another Nano service to get its data. So that was the most read, you might recall. This is the actual most read data. You can kind of see the North Korea thing up there. 22,000 people, is it, who's read that in a 5 minutes period? So that's what it's using to power itself. And again, that's another Nano service. If we look at that code, standard Node stuff going on here. You have your index.js and you have your own tests and build scripts and so on. So it feels like anything else. But again, one file with 200 lines, and you can kind of see, what's going on there, the various commands, make the API call underneath, then pass it and check for various bits and blah, 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 and return it, right? So it's wonderfully straightforward at these levels to use it. So what are the advantages then? They are these Lego bricks. I hope that came clear. These different things that you can share in different ways. They're easy to understand concepts. Sometimes we'll have third parties write code for us, and then it'll be brought in-house. Have you had that happen? When we've tried to get internal teams to look after code written by third parties, there's normally a war. Whereas what we found with these nanoservices is they get them because each thing's an understandable thing that you can work out what it is and you don't mind looking after that bit of code and you can release it and play with it and change it. These become more shareable bits of code. It should be good value because you've got a highly cacheable shared infrastructure going on there. It has a set platform from which you are, it looks after the operational side, so people can concentrate on building the thing they really want to build, these nanoservices. The deployment's fast, just copy into that S3 bucket, and all of this, the whole reason we're doing any of this is to speed up the rate at which we can make new things. Challenges, it's a single point of failure. This platform, although it's nicely distributed across AZs and so on, there's always that logical thing. If you have a problem in how the thing works, there's a lot of nanoservices that are going to fail. So it has to be a bit conservative as well, because you can't have one hogging up all the resources for all the rest. That means it can be restrictive. So this wouldn't be a good way to make a video transcoding platform, but it is very good at making kind of relatively fast APIs and web pages and that kind of thing. It's not very fast. I think it's in italics. It is fast. It is fast. But of course, you've still got the overhead of talking to Elasticache and the shared platform and so on. So if every millisecond counted, you perhaps wouldn't do this, but it is still fast. And you do need really good tooling to understand what's going on. Because do you remember that graph of all those hundreds of nanoservices? You do need to understand who's building what, where, when, what's changing. Do you remember this slide on the microservices? We can compare it with nanoservices. Yes, multiple teams can do it. Multiple tech actually gets a bit harder to do multiple tech because you're sharing. But I think there would be potential to do that, so I'll put a question mark there. The deploys are definitely even smaller and safer. It is definitely very shareable and very flexible. You can use these bits in different ways, and it is more scalable, I'd argue, as well, because you've got this platform that can handle any one of your nanoservices at any point, which of course auto-scales like all good cloud stuff. In terms of the cons, one of the really big things for us is we've killed the maintenance overhead of having to run all of these microservices because you've now got one shared platform looking after it for you. The comms overhead has gone as well because, again, that shared platform, if one nanoservice needs to call another, not a problem. It's just there in the same place. There's no separate system that needs to be called. The multiple version challenges have kind of gone away because you can have as many versions as you like lying around in the S3 bucket ready to be run, which is nice, which then also makes refactoring easier because you can change the whole stuff. And cost should be better. I've put a dotted line for cost because cloud cost engineering is the hardest thing known to man, isn't it? It's really hard to keep things cheap. We need to do some more work on that. I had a little bet with myself as to whether I'd get away with putting other cloud providers' logos on my deck, and somehow it got through the thing. All three of them are, of course, the serverless offerings, Lambda, and as the BBC would say, other cloud providers are available. And what can we say about them? They're all fantastic, but they're all perhaps early in the journey towards serverless, right? There's phenomenal potential in a serverless way of working. And no doubt there'll be some announcements this week, but there's so much that can be done with them. And why should they have all the fun, right? The architecture we just talked about is kind of like a serverless way of working, right? There's obviously servers behind the scenes, but they have servers behind the scenes as well. To the developers writing nanoservices, it is serverless. You upload your code, and the magic happens. So, as I say, it is serverless. We didn't use Lambda. I suspect our architecture will evolve to eventually use Lambda an awful lot, maybe entirely. We didn't today because we needed such fast response times. We wanted to use Redis queues, and there's no direct way of calling a Lambda from that so that you could make one. And we were worried about, there's a lot of APIs we call that can take a while. And of course, if you have a Lambda calling an API that's then waiting for that API, you're paying for a Lambda to do nothing. So that's why we haven't used Lambda so far. But as I say, I think we would probably move to that very much so in the longer term. It could be how you do a lot of this. But I do think it's interesting. They call Lambdas functions, and the other providers do as well, right? And they're great for those smaller, event-driven, something off a queue or some triggered by some change in Dynamo or whatever. Lambdas are fantastic for that. For larger systems, are they yet fantastic? Do you know Simon Wardley? Another Brit. He's very good at kind of helping predict technology changes. And he talks about how serverless is going to fundamentally change how we do stuff. Expect to see the whole world being overtaken by serverless within, 8 years? That's amazing, right? That is, think of all the server software we have or that we're making, all being done serverless within 8, 10 years. That's going to take some pretty interesting thinking, right, about how we do that stuff. And so in this world, then, where things are serverless and you don't need to worry so much about that practicalities of running stuff and configuring stuff so much, why not design your software, your really big software, as a series of small logical things that you can release and use in different ways, right? And so, just a thought, could this Nanoservices idea be a paradigm for us building really big stuff on serverless? Netflix launched a blog a few months ago that says almost exactly what I've just been talking about. We think they must have a mole because the idea is bizarrely the same. They've even used serverless like in there. The one thing they didn't do is use the word Nanoservices until they launched part 2 a few weeks ago, in which they did use that word. So it's quite scary. And we've also made a blog on it, should you wish to read more. So that is pretty much it. They have brought us that ability to share large teams to work together, building things independently, but still allowing flexibility to make all kinds of different things in an efficient way, all of which there to drive velocity, the speed at which we can release stuff. So, if you didn't know already, hopefully you've seen some examples of where Redis can be extremely flexible as queues, not just as a cache, but for your metadata, as a way of communicating, as a full message bus, which can be really interesting when building serverless-like things, because you can use that as a way of communicating between them and orchestrating what they're doing. And then the nanoservice pattern of basically saying small-ish things that are still clear on what they do and how they're tested and released and so on, could be a really interesting way of working in order to allow lots of teams to work on different things while still getting continuous delivery and all those benefits. That's it. Thank you.